Hello, everyone. Welcome back to the Keys to AWS Optimization, and welcome in 2026, kicking off with a new year of exciting FinOps stories. So welcome to the show. The show we share stories, concepts, and solutions to help you unlock your spend at AWS. We'll do a round of intros to kick us off. So hi, my name is Steph. I'm an SA advocate here at AWS, here to help you on your FinOps journeys. Adam, do you want to go next?
Sure, Adam Richter. I'm a solutions architect that specializes in optimization. So I help some of our biggest customers run their workloads more efficiently.
Perfect. And Liam?
Yep. Hey, I'm Liam Greenemeyer. I'm a principal product manager in AWS billing and cost management. And specifically, I focus on our AI for FinOps offerings. And I've been with Amazon for close to 8 years.
Brilliant. And you might have seen these guys on the show before, and you'll probably see them again at some point because we do a lot of AI content in the world of FinOps these days. But in today's episode, we're going to be looking at both FinOps for AI and AI for FinOps. We're going to dive into a little bit about what those things actually mean. But this session is going to talk about the best ways of optimizing when it comes to your AI. So looking at commitments, utilization, tokens, and stuff like that, before we move into AI for FinOps, where we're going to be doing a demo, a live demo. So make sure you stick around to the end for that, where we're going to be looking at different cost optimization use cases that we talk about in the start, but actually what that looks like in the terminal. Hello to everyone in the chat. There's someone from San Diego watching. Thank you for coming up early. I love it. Hello, everyone. Hi. That comments box is there for you to ask questions throughout the episode. But if you're watching us on demand and on YouTube, then why not drop a comment below? Let us know what you enjoyed about the episode or any questions you have for us. Someone says stock prices are going up every day when I say AI. If I have that much power, I would be surprised. But we're going to take a step back before we dive into the demo and talk about where this topic and discussion comes from. Adam, this was your and Liam's reInvent talk, right? So you did it as a chalk talk. Do you want to kind of set the scene of what we're looking at a little bit?
Yeah, me and Liam, we're really brainstorming how to condense as much value as possible about this topic into our kind of small 1 hour session. And to double down on what Steph said, it was a chalk talk. So we really were excited to be in the room with customers that had questions about this stuff and that could talk to us in real time. So I'd encourage you to do the same. Those of you that are joining live, like if you have questions along the way on anything we're talking about, or maybe even just stuff related to what we're talking about, drop those in there and we'll do the best we can to answer those during our time together. But really the goal was to look at both sides of the coin. FinOps for AI, which is using those FinOps practices to maximize the value of the AI that you're running on AWS, kind of across the whole gambit.
And this was a 300 level talk, so we're assuming that you've got some background, at least a little bit, in cost management and AI, and I think that really helped to set the stage for a really good, productive discussion in the room, and I'm hoping we can do the same here today.
Yeah. And yeah, if you haven't seen, go back and have a look for any keys to AWS optimization episodes around AI. We did a couple last year to kind of set the scene. But the good thing about these two is we're talking some theory and then some demo with some practical use cases. I'll flag up a couple of these comments. Hi from Canada. So many days. It's been ages. Yes, it's been a whole month since I've been on this live stream. I'm sure you've all missed me terribly. And we just had a question, which is, how can I remember what way round FinOps for AI and AI for FinOps go? I also struggle to remember this way round. So, guys, what's a good tidbit of how to do it the right way?
I've got a trick, but Liam, how do you remember it?
I don't know. I focus mainly on AI for FinOps and less on FinOps for AI in my day-to-day life. So, but Adam, maybe you have to switch more. So.
Yeah, I definitely switch between both a lot. And I think I also hear a lot of those getting used kind of synonymously and interchangeably. Mm-hmm. But if you just put the word like using in front of each of those, it kind of helps to make sense of them, right? So using FinOps for AI or using AI for FinOps, it kind of makes it make a little more sense so that you're using that tool to do the thing. So that's how I remember.
tips. Yeah, top tips from Adam. I love it. And one more, cost layer in the house. So AI can be more than a little shiny object. Most vendors are like, hey, just me too. I mean, at the moment, the world is coming up with a lot of AI, and the more, especially as FinOps practitioners, can understand how it works, the better we're going to be, because it's going to be the new thing that we are cost and build on. With that, let's get into the topic. Actually, before we do, I just want to shout out one thing that I was thinking about the other day, and I wanted to bring to everyone's attention. Phops X is coming up. So I actually thought I'd do this every episode to see, we'll see if we keep it going. But Phops X 2026, I am already started thinking about what I would love to talk about at this event. And I can't wait to see all of the new exciting topics and challenges and how AI is in this discussion. But I just started, I was like, okay, let's do a little bit of a countdown. Let's figure it out. So let us know in the comments if you're thinking about going to Phops X this year.
This is it's a stressful countdown timer for me because I am planning on launching things at FinOps X. So that's the that's the time that I have to get this launch ready.
Wow, now we know about that. People have got to go to FinOps X. So yeah, I'm excited to think about it. I'm already thinking about booking my flights and getting ready for it. But let's get into today's topic a little bit deeper. So Adam, let's talk about getting started with FinOps for AI, which is, I feel like every single time I say it, I still have to be confident. And talking about simple ways of optimization, we're going to kick off with commitments, which is kind of a fundamental thing with cost optimization and savings. But yeah, how do we start this?
Sounds good. So I've got a couple of visuals to share, just that for those of you that are tuning in or watching the replay, feel free to grab a screenshot of these. It'll help make some of it make sense. And as Steph was pointing out, I've got kind of the three top ways to save and optimize AI. One is commitments, then we're going to be talking about utilization, and then lastly, token compression. So for commitments, I'm not going to dive into the details of savings plans. A lot of you that are attending here probably already know, and as Liam pointed out, this is kind of like higher level. But I do want to talk about some of the nuance around how I'm seeing large customers use commitments for AI, and then some of the other things that are types of commitments that you may not even be aware of. So firstly, with savings plans. So what I'm seeing customers do differently with these compared to kind of the normal strategy, which is buy compute savings plans in a central payer account, or occasionally buy instance savings plans for specific instance families, like, P5s or something along those lines. Mm-hmm. What customers are doing to try to make sure that they're getting their AI workloads covered is inside of specific linked accounts where those AI workloads live. They'll buy a 3-year compute savings plan in that account so that they ensure that all of those AI EC2 instances are covered first. And then once that's exhausted, if need be, that compute savings plans will go apply elsewhere in the account. Also, I'm seeing a lot of customers do 1-year instance savings plans to cover that compute because, as many of you keeping track of, NVIDIA comes out with new chips all the time. At Amazon, we have new Trainium and Inferentia chips. And when you buy an instant savings plan, you have to flag and kind of raise your hand and say, this is the family that I want it to cover. You get greater discount, of course, but to ensure that you're not overcommitting and kind of locked into a family for 3 years, I'm seeing some customers just do 1-year instant savings plans. So they figure that we'll at least stick around for that amount of time and then move on. So that's some nuance, I guess, in the kind of the savings plan world that I'm seeing some customers do. The one overlooked one, though, for EC2 is capacity blocks for ML. And this one kind of made rounds in the news recently with some pricing changing around how it's offered. But what these are is you, instead of having to commit to 1 or 3 year like you would do for a normal savings plan, you can commit for a shorter period of time. So think like 3 days, 7 days, up to 182 days. You schedule and say, I want these accelerated compute kind of AI instances for this short period of time. You basically reserve that capacity, and in exchange for that, you actually get a better rate than you would get if you just launched them on demand. So the savings, when I've calculated for kind of some of these, tends to be in like the 30 to 60% range, which is still excellent in my opinion. Even some savings plans at the lower level offer kind of similar ranges. So if you're not already doing these or looking at these in your environment, they're a great way for people that are just doing a training project or just doing something where you need that capacity for a finite amount of time. Look into capacity blocks for ML.
Yeah, we've had a
I'll pause
question,
there,
which is
yeah.
when would you use capacity block? So specifically for workloads where you need a little bit more of this and it gives you that saving. Is that as simple as? Is there any other use cases apart from maybe some trainings? Or are there specific applications that would need that kind of short-term capacity?
So think of, so training was one, but think of short-term projects too, right? Like if you're just doing kind of a proof of concept in a testing account or a dev account, and you don't want to commit to capacity for a long period of time, but you also don't want to pay for it at full on-demand prices. This is where capacity blocks for ML are great. Another thing, I guess, here that I didn't say is that if there's capacity available, you can also extend these. So when you're nearing the end of the, say, 7 days that you reserved and you realize, oh man, we actually needed 8 days. If there's capacity still out there, you can actually extend these to, say, that 8th day or a 9th day. So they have some flexibility. Keep in mind, obviously, if that capacity is not available, you're not going to be able to extend it. So these things operate, a little bit flexibly in that regard.
Awesome. Okay, anything else on this one?
No, I think that one good. So let's jump to SageMaker. So SageMaker, well, I'm back real quick, sorry. SageMaker also has its own savings plans. Just keep in mind, those are separate from the EC2 ones. So if you buy one or the other, they don't cover each other. But SageMaker also has these things called HyperPod flexible training plans. So, long mouthful of a name, but they operate almost exactly like capacity blocks for ML. So if you need to use SageMaker for, again, a short predetermined period of time, you can get a better price by purchasing these flexible plans. And then lastly, in Bedrock pricing's changed a lot recently, and it's continuing to change. For a while, we had provision throughput. So that was like a way you could commit to, it was like a capacity block in a sense for 1 or 6 months. There wasn't a lot of models supported, and it was a little bit tough for customers to figure out how much of those they needed for a period of time. So more recently, Bedrock's pivoted to this pricing model where there is standard, priority, flex, or reserved. So standard is just normal. That's like, think about that like you're on demand. Yeah. Priority comes with a premium. So with priority, it's about a 75% higher price, but you get higher priority. Basically, you get put to the front of the queue so that you're, think mission critical stuff that has like sensitive latency times, you'll want to use priority. Flex, on the other hand, is actually 50% on average cheaper, but then it's kind of best effort, first come, first serve. So it might take a little longer to process that. Lastly, though, reserved. Reserved is the new one. So reserved lets you, for 1 or 3 months, be able to pick a, kind of like you do a commitment, $1 per hour, but you pick $1 per like 1,000 tokens. And you can actually reserve capacity for models like Opus, Haiku, and Sonnet. Previously, it was just Sonnet, but a day or two, they added Opus and Haiku 4.5 also. So these can give you a little bit of a savings over a term as well, if you know for sure you need at least a certain amount of capacity. So a lot going on here. That's why I put this on a picture. Feel free to snag this and go kind of look into these more if you're using any of these in your environment. There's savings to be had, and that's the easy button in FinOps, right? You don't have to change anything in the architecture. You're just kind of raising your hand and saying, like, for a dollar amount or for a period of time, I'm going to keep using these things, so I should get a better rate. And that's what those things do.
Yeah. Okay. And it's as a reminder, I feel like hopefully in the chat, give me like a yes or a 1 or something if you're using normal savings plans. I hope everyone watching in their business is doing that. And the thing that we want to make sure is that the thing that when we SageMaker, people miss it quite a lot, that they're actually that's available. It gets kind of hidden. So start to look at your workloads and start to build that up gradually. But another thing I should recommend is there's so many changes when it comes to things like Bedrock and all these new pricing models and stuff like that. Guys, you've got to subscribe to the channel you're watching on to make sure that you keep up to date with all the updates, or follow us on social media, wherever you get your social media from, especially LinkedIn. And I'll share a link at the end of where you can catch us on LinkedIn, because these guys, especially, is why I bring in these experts, because I didn't know that. So I'm not going to pretend I'm always up to date on everything. So we want to make sure that we keep learning.
Adam had to update that slide, I think, several times before our re:Invent talk. And even now, it's still out of date, because if we're looking at the total universe of savings plans, it doesn't cover the new hotness, which is the database savings plans.
New hotness is brilliant. Well, make sure, another plug to subscribe. I'm on a subscribe train today. We're going to be having an episode on database savings plans, a deep dive and using savings plan analyzer later on in a couple of weeks. So make sure you stick around on the channel for that. A couple of questions. What's the minimum duration for a capacity block? Can we pause or reduce duration if needed, like 10 days to 8 days? Adam?
Can't reduce it. I feel like the minimum was like 1 day, and then after 7 days, I think you had to go in like 7-day increments. It's definitely out there in the docs, but I'm pretty sure the minimum was 1 day, and you definitely cannot reduce because you pay for it up front when you reserve
Okay.
that time period.
I'll throw that to Richard to go and grab the doc for us and drop that in the Twitch chat if that is possible. Brilliant. Okay, so we've established a good baseline when it comes to commitments. Like you said, what we can do without changing the infrastructure. Folks, any other questions, drop them in the chat. Should we go to what this kind of spend looks like in the console, Adam?
Yeah, so let's talk about utilization if you want to bring up the ODCR slide. So kind of the next key pillar to optimizing your AI is understanding how it's being used. So just because somebody is running an AI workload doesn't mean that they're running it well. And ODCRs are one of our tools to reserve capacity. So say you needed 10 P5 instances, you could use an ODCR to protect 10. Why people do that is so that you have 10 and say somebody reboots one, you don't lose it to the kind of the pool of people that are trying to pick up that kind of capacity. Problem is though, if you're protecting 10, sometimes teams downstream may only be running 8. Well, if you're protecting 10 and running 8, you're still paying for 10 as if 10 were running. And one way to detect if that's happening in your environment is to monitor the ODCR unused. So as you can see in the screenshot, there's usage types in Cost Explorer that you can filter by called unused box or unused DED. Similarly, though, CloudWatch, AWS Health, or even in the Cur data, you can find the same stuff in any of those places. So whichever tool you're most comfortable with. But once we detect this, we can see, okay, how much of our ODCR is not being used? And then we can talk to those teams and say, okay, hey, you're protecting 10, but you're only using 8. You either need to launch those other 2, or let's adjust our ODCR down to 8. And then that'll be a savings in your environment. Now, something overlooked here is we could have that conversation. They could just go launch 2. And if they launch those 2, this graph will then be empty, right? Because they're running all 10. Then we don't have any unused. So the next part of that, like that we need to think about if you want to jump to the next slide is, okay, how well are they using those instances? Just because they're running, they could be sitting there idle and not doing anything. And with GPU-based instances, we don't have the same information that we have for like a normal CPU-based instance. With a normal CPU-based instance, those get picked up in Compute Optimizer, right? And we get recommendations and we know if they're underutilized. With a GPU-based instance, you will not know how well that GPU is being used unless you have the CloudWatch agent enabled with the NVIDIA metrics, or depending what kind of instance or accelerator you're using with those additional metrics. The CloudWatch graph you see on the screen, this is a real example from a customer server. So this is a single, I think it was a P4 DE24X. So this is a NVIDIA-based instance that has 8 GPUs. And that's what you could see kind of along the bottom left of the graph, the 0 through 7. That's each of the GPUs. With those metrics enabled, we were able on this server to say, okay, how well are those GPUs being used? And as you could, and what this was being used for is taking MP3 files and transcribing them. And it would do it in batches of 8 MP3s. So we could see kind of from the left part of the graph, there's just a single blue line. So basically what it was telling me once I seen this was, hey, you're using 1 of your 8 GPUs to transcribe those files. You're getting 1/8 the power of this server because you're not haven't deployed it properly, you haven't configured it properly to actually use all of the GPUs. So what that resulted in is, 1, they're getting 1/8 the benefit of the server that they had launched. Also, 2, it was taking a lot longer to transcribe those 8 different MP3 files because it had just 1 GPU working on it. So as we can see kind of to the right side of this, once they fix that, you see all these colored lines come in. That's because now all 8 of those MP3s, they were able to update their script to be able to use all of the GPUs to do the transcription. So it not only finished faster, they're able to process more MP3s, get more benefit and more value out of the server that they're running. And sorry, Steph, I think you had a question there.
Yeah. So when it comes to the change in configuration for the GPU, is that a inside of the code itself for this app that's processing the files, or is it an infrastructure change? It's the code.
It's in the code that's running on the server itself. So like in their case, they were just telling it, hey, transcribe. So by default, it was using a single GPU, kind of a single, think of it as like single threaded. And then once we realized it by looking at the data, we were able to say, hey, you've got, in a sense, 8 GPUs or 8 threads. Let's make this thing multi-threaded. So that's the best analogy, I think.
Yeah, that makes sense. So keep an eye out for this. And then is this a default dashboard, or did you have to configure this one yourself?
So this one I configured manually by going in and pulling up the server. So there's no like automatic dashboard for this. Okay. But I guess one thing I glossed over is some people are a little gun shy about enabling CloudWatch, installing the agent, enabling the metrics, because it does have a slight additional cost. But for servers like these that are, you know, 40, 50, whatever dollars an hour, even turning on all the NVIDIA metrics for the whole month, it amounts to maybe $3 for the whole month to be able to get this kind of intelligence, though. And I believe that there's a lot of potential underutilization going on in these instances that is getting overlooked without this stuff being enabled. Second benefit, once you've enabled this, Compute Optimizer picks it up. So it also becomes aware of this stuff and can give you recommendations.
Yeah, it makes those recommendations a lot safer in terms of, well, sorry, it doesn't make them safer at all. It makes them a lot more accurate so that you can downsize in other elements. So especially if you put in things like memory metrics, then Compute Optimizer will never suggest an instance that's a different memory because it wants to be as safe as possible. So to get the best cost saving, you enable it. A couple of questions before we move on from the slide. Number one, what is the 350 none measure for? So what is that axis talking about in this case?
Did I say 350 none, or is it on a slide?
No, it's on the slide. It's the
oh, gotcha. So this is the in this case, it's the power draw was this particular metric, which you could get into the nitty gritty, but it's how much power each one of these are using. There's different proxy metrics for trying to figure out how much a GPU is being used. Some people use temperature to see how hot it's running. Other people use power draw. So there's different, I guess, levers you can lean on. They're just rough estimates of though how strongly it's being used.
So there's no CPU in the same kind of...
Nope. As a matter of fact, people often confuse that because there is a utilization GPU metric. But if you were to look at that metric, it's a 1 or a 0. It's just telling you, yes, the GPU is being used, 1, or 0, no, it's not being used. So it's not like a CPU kind of 0 to 100% type thing.
Yeah. And there's another question, which is, are there other measures we should consider for GPU utilization outside of the CloudWatch metrics? Well, we just spoke about obviously temperature and this power one, but is there anything else? I don't know, Liam, if you've ever dove into, will we talk about your section later, if that's going to be covered at all, the utilization element?
Yeah, we'll dig into how to look at the utilization and the temperature. I mean, I think for FinOps types of use cases, utilization is probably the most important one. But obviously there's sort of a whole suite of metrics that you can look at if you really want to get pretty deep into the hardware level performance.
Awesome.
Yeah, the 3 most important are temperature, power draw, and then memory use. Will tell you how much of each GPU's memory is being used.
Good to know. Awesome. And we had another question, which is this one, which is question for the experts. I'm wondering if it exists. Can we feed AI model a Kira file and ask it to write out a summary of costs? Yes, you can. The way I would go about this is a low effort. If someone's put, you can use your MCP. That's D&D. It's NPC. We're going back to a D&D chat. Another channel. I'm sure that's on. So what I would recommend doing is, if you haven't already, to deploy the Cloud Intelligent dashboards in QuickSuite, which used to be QuickSight. And in there, you can add these dashboards to an agent in QuickSuite and have a conversation with it and start to ask it questions in there. That way it can grab all of your data and start to look at this. Or you could also connect it to the bucket and have the raw files. But that is a great way to kind of get all that data in there and start to analyze what's going on. So that's a challenge for you to go and check out.
Right. I'll call out there too that you can, it doesn't rely on the cost and usage report, but you can also just hook up the billing and cost management MCP server, and that can give you a summary of the costs in the account. It depends on Cost Explorer APIs rather than cost and usage report. But aside from that, it sounds like that's largely what you're looking for there.
And there's a link to that below. Brilliant. All right. I know that we want to move on to the demo in a short moment, but Adam, do you want to cover the last bit very quickly before we go into the demo section?
Yeah, I'll do a 2-minute summary on token compression. So you want to bring up that picture for those of you here, grab a screenshot if you want, because there's a lot of detail here. But tokens are the currency of AI. So whether you're doing it in something like Bedrock, where it is price per token, or if you're running your own models on accelerated compute instances, the amount of tokens going in and out determine how much it is being used or how little it's being used. So the more we can compress or shrink those, the more value we get out of our resources for the same price or less price. So a couple ways to look at this are on the prompt side. So the prompt is the question we are submitting in. How do we make that smaller? Because when we ask a question to AI, we tend to give it a lot of extra words that AI doesn't need because we're speaking in like our native language. AI just needs like kind of the key points to be able to figure out what answer to give you. So a lot of times the prompt or the question that we're asking can be compressed. That could be done in a couple ways. One, using a smaller model. So think something cheap like Haiku. You give it the question, say, hey, shrink this so that it can be smaller. Two, using a purpose-built model like LLM Lingua that specializes in compression. It can like remove words and abbreviations and things along those lines. Lastly, if you're getting repetitive questions to your model, we don't even need the model to process that again every time. You could use things like prompt caching, where it already knows the question and it's already created an answer to that question. So instead of having the model do that inference to give you a brand new answer every time, it'll say, I've gotten that question before. Let me just answer it from my cache and give you what it has there. Now flipped to the response side. So generally response tokens are about 4 times more expensive than input tokens. So oftentimes a lot of people put emphasis on response. And that makes sense, right? Because it's not hard for the model to get and receive the question, but it has to do all that math and all that crunching to be able to formulate an output. So oftentimes tokens are 4 times or so more expensive. To be able to compress this, you can do things like system prompt. System prompt is basically just instructions that get tagged along on the back end of the system that tell it how you want the answer to be formatted. So if you want to jump one more slide ahead, I think I have an example that probably explains this the best. So this is an example, might be somewhat small for you to see, but basically I just asked AI, Nova Premier, what are the top ways to cost optimize Amazon EC2? On the left, and this is by the way in the Bedrock playground. So if you've not gone in there and tried stuff, it's a pretty fun place to check stuff out. On the left though, it gives me a pretty long output. And you can see at the top, it said 12 input tokens, 400 output tokens, and it took about 6 seconds or 6,000 milliseconds. I gave it a system prompt. The exact system prompt I gave it is right here in the middle. I gave it the exact same question. What are the top ways to optimize EC2? So we can see the example of the output on the right-hand side. It was a little bit higher on the input tokens, right? It went from 12 to 37 because I had to include that system prompt into the input. But the output tokens shrunk from 400 to 90, and it was a little bit faster. Similarly, we could ask follow-up questions about these things. But this transaction alone, the single transaction, was 75% cheaper because of using that system prompt. So as we get into the days of like agentic, where a lot of these inputs and outputs are going to be consumed by other AI and maybe not even by humans, formatting this output to just give it what it needs, whether it be a percentage, a yes, no, a true, false, like we don't need it to give the big verbose long story when sometimes it just needs to be a smaller, succinct answer. So keep that in mind when you're designing these things.
Excellent synopsis. The token, I think I'm going to do some more deep diving into some token analysis this year, based on some stuff that Adam and I talked about. Reinvent, great time. Got some ideas for the year. I'm excited for some things I'm going to be putting out into the FinOps universe for this year. Before we move on to Liam's, just saw some comments in the chat. As a reminder, you can always email costoptimization@amazon.com if you have any follow-up questions about today, if you want to share that you've learned something, or you can always comment on the YouTube video below when we're done on that, and I will kind of keep track of those. But we've learned all of this summary of kind of the commitment element, how to look at utilization, and also how to optimize our application when it comes to Bedrock. But we want to give you some more practical elements that you can go and have a look at. So Liam, we're gonna do your kind of demo elements, but do you want to set the scene at all before we get into it?
Now let's dive in.
Let's just dive in. All right, excellent.
Yeah, let's just dive right in. So, I mean, what we're going to do here is we're going to look at using Kira and the billing and cost management MCP server to actually help us identify some savings opportunities related to the use cases that Adam just walked through. So I'll start by taking a minute here and just kind of explaining the setup here. So I'm using the Kira command line interface. If you haven't used this, this is a really great tool, whether it's for agentic coding or increasingly just for day-to-day work, non-coding work, and for FinOps as well. So what I'm using here, I've got 3 MCP servers hooked up. I'm going to run /tools just to show you what I've got attached here. So I've got the AWS Knowledge MCP server. This is sort of a documentation search MCP server, so I can use this to help the AI understand AWS services. We've got the billing and cost management MCP server, and we've got the CloudWatch MCP server hooked up. And the model I'm using here, I am using Sonnet 4.5 with a 1,000,000 token context window. So let's dive in. The first thing I want to look at here is, let's say I need to spin up a P4D.24x large instance for a week. How much would I save using capacity blocks for ML versus on-demand pricing? And let's take a look at how Kira is going to help answer this question. So first thing it's going to do is it's going to use the billing and cost management MCP server and its AWS pricing tools to start retrieving information about the on-demand costs. And what you can see here is that Kira is asking me whether to allow this action or not. So I can either say yes, and that'll allow that specific action this one time, or I can say T for trust, which will allow that action for the remainder of this conversation. In this case, because I know that the billing and cost management MCP server is all read-only actions that are safe, I'm going to hit T and let it go ahead with the data retrieval. So it's going to make a few different calls here. It's getting the relevant service codes, getting the attributes of this service code, and now it's using that information to actually query for the pricing information here. Okay, and it tells me. So it tells me I can see pricing data includes capacity block entries, but they show 0 per hour. This is because capacity blocks are purchased as reservations for specific time periods, not per hour. And so next thing it wants to do is search documentation to get better understanding of the capacity block pricing.
The AWS knowledge one, that's like, I feel like I leave that in that now. It's a good base one to have when it comes to developing with Kira, right?
Mm-hmm. Yeah, absolutely. I mean, if you're building on AWS, it's just great to have your AI assistant or agent really understand how these AWS services work and be able to search it much more efficiently than you sort of clicking through those user guides. Okay, so what I can see here is that it was able to get me the on-demand pricing from the price list APIs, and then it was able to get me the capacity block pricing from the documentation. But let's make sure that that pricing is up to date and that there's actually capacity available, because the capacity availability is going to sort of fluctuate based on supply and demand. So I'm going to say, can you check whether there's actually any capacity available and verify that those are the up-to-date prices?
And while that's thinking, like Liam didn't point this out quite yet, but like you could of course go do all this stuff manually. but you'd be
Oh,
going
yeah.
and sifting through documentation, the pricing calculator, doing the comparison. Even with just a few simple prompts, he was able to see that it was something like 40-something% savings between doing these two. So if you're trying to help, somebody downstream on a team from a FinOps perspective get an answer to if they should do a capacity block or not, and they just want to know the difference in the pricing, these kind of tools can super accelerate you getting those kind of answers without you having to go dig through a bunch of stuff manually.
Yeah, for sure. And generalizing from that, that's one of the big reasons why I think it's so helpful to use AI tools like this. It's not so I can just totally shut my brain off and let the AI go do whatever it wants, but it prevents me from having to know a lot of low-level details in order to, get the information or make the decisions that I need. So, for example, somebody could go, read the CLI documentation for exactly how to get capacity block offerings from the EC2 API. Or I could just ask the question that I just asked. So it saves me a lot of sort of low-level cognitive effort and lets me focus more at a higher level on what's actually important.
Yeah, someone's put saving the most valuable currency, time. That's what we want to save here. Time is money. I have a question just before we move on, which in the chat, which is, what do you do if a couple of your MCP servers are having trouble loading when you start Kira CLI chat? It just takes them, correct me if I'm wrong, guys, sometimes they take longer to load, and so they will eventually get there. But if you do /MCP, Liam, if you could demonstrate if I've got this right, then it will show you what's loaded. So give it a few, you can see how one of them took 1.5 seconds and one took kind of whole other second. That seems small in this case, but if you have a lot of them and they're quite large, then it might take some. So just kind of check before you start building. You can use that /MCP to validate it.
Yep, and if you've got a problem with your mcp.json configuration file, that can also cause issues sometimes. And other than that, it could be like a dependency problem on your local machine. If you don't have like proper dependencies installed, or there's some sort of dependency conflict.
Yeah.
Also,
I seem to get it with the profile. Okay.
You don't have to use these just in Kira CLI. If you have like VS Code or Cursor or Claude Desktop, like MCPs can connect in anywhere that they're supported. So you can use these in different places too.
Yep. Okay, so what's next? So the next thing that Adam showed us was looking at GPU utilization metrics and really evaluating the performance of our GPU-based instances. So let's take a look at how that would work. So I'm going to start again here with sort of a vague or kind of high-level question here. I'm going to say, an engineer on my team spun up a pretty expensive GPU-based instance this week. Can you find it? Tell me how much we spent on it and check the GPU utilization.
And with this, you're already logged into an account, so it's going to just be focusing on that one account that you're in, correct?
That's correct, yeah. Okay, so what it's going to do first is try to query Cost Explorer. Okay, it says no GPU cost showing up in Cost Explorer yet. We're going to come back to that here. But the next thing it's doing is running EC2 describe instances. So here it's using the command line interface directly rather than using one of our MCP tools. It's just using a CLI command. This is something that Kira can do just out of the box. And so it found the instance we were talking about, P4DE 24x large, and it's going to get the cost and GPU utilization. So what we're seeing here is it's actually triggering 2 tool calls at the same time, which is great. It's something that the Sonnet 4 models are particularly good at. And so the first thing that it did was querying Cost Explorer to get the data, the cost data for this specific instance ID. And then it's querying CloudWatch using the CloudWatch MCP server to try to get the GPU utilization. And let's see what it's telling me here. So GPU utilization metrics aren't available, requires CloudWatch agent, which is exactly what Adam said. Let me check if there are any custom GPU metrics published. So now it's running CloudWatch list metrics, so getting all of the metrics that are available on this instance. And then it's going to try to check CPU utilization as a proxy and then check for custom namespaces. So let's see how it does here.
While you're doing that, there's some chatter in the comments, which I adore, which is that you're very fast at typing. Yeah, that's the feedback we've got, and sounds like a mechanical keyboard. Is it a mechanical keyboard?
It is. If we get done here, then I can, hold up my keyboard and show it off for the people.
In that, if you've gotten to this point in the video and you're watching us on demand on YouTube, drop a keyboard emoji in the comments for me to vote to see Liam's keyboard.
Yeah, please rate my clickety clackiness on a scale of 1 to 10. And if I need to, I can upgrade.
The thought is more, would I want to sit next to you in the office? Probably not.
Hold on, Steph. The stream includes ASMR, so this is for all the people that love the keyboard sounds.
Yeah.
You're getting 10 out of 10.
Okay, excellent. So let's look at what Kira actually came back with here. So it found the instance. It found the costs for the specific instance, and it's breaking them down by day here. And it successfully found the GPU utilization metrics. So 98% average GPU utilization across all 8 of the GPUs, running at 100% for most of the time, brief dip to 69% today. And then it also got CPU utilization, which I didn't ask for, but that's fine. And is telling me that they're being used pretty effectively. So this is great. It kind of got all of this without me having to point it in the right direction. But let me go back and actually show a little bit about kind of the path that it took here, because I think that this can be instructive for actually using these tools and these MCP servers in real life. So first thing that I can see here is that in the first Cost Explorer query, it tried to filter for an instance type family called GPU instance. And that isn't actually a valid value, right? And so it came up with 0, and it showed no GPU cost showing up in Cost Explorer yet. So in other times where I've run this, I might have had to gently nudge it in the right direction, either by saying are you sure, or can you double check the Cost Explorer costs, and that might prompt it to just try to query for it in a different way and get the right answer. But in this case, it actually sort of self-recovered, because once it ran EC2 describe instances, got the instance ID, then it ran a different Cost Explorer query where it filtered for this specific resource ID, and then it successfully found the cost data. So this is actually, sort of a feature of these AI systems, is that they can oftentimes, when you've got a smart enough model, it can sort of gracefully self-correct mistakes that it makes. And so that's really helpful. The other area where I saw it sort of start to go down some wrong paths is it tried to query for a metric called GPU utilization in this namespace AWS EC2. And as Adam talked about, you need to enable the CloudWatch agent to capture these metrics, and they actually show up in a different namespace. So, again, here it told me GPU utilization metrics aren't available. It requires the CloudWatch agent. But then it said, let me check if there are any custom GPU metrics published. And so it actually ran CloudWatch list metrics, got all the metrics. Well, first it actually tried the same namespace, so that's not going to come up with GPU utilization. So it queried CPU utilization, kept trying, very persistent. So it ran list metrics with no namespace filter. So get all the CloudWatch metrics on this instance, and it found the GPU utilization metric name from the DL-AMI/GPU namespace, and that was how I was able to actually get the information that it needed. So in this case, it actually went down a few wrong paths, but without me having to prompt it, it self-corrected and actually got me all the information that I was looking for. But in other cases, like I said, I've sort of had to nudge it in the right direction to get the information that I was looking for. And I think that's just an important skill to be able to have as you're using more of these AI systems is to be able to keep track of what the AI is doing, and if something doesn't smell right or doesn't seem right, again, not turning your brain off, but sort of reprompting it and asking it to double check or try something else can be really helpful.
Yeah, especially because at the start you knew in your kind of persona that someone had started this instance. So the data, just because it couldn't find something at the start doesn't mean it shouldn't be looking. But what's also really good is that if you think about it, we think about it from a FinOps professional who maybe, if we go for the non-technical persona, or even like I call myself technical, I don't know the filter off the top of my head for what would count as a GPU instance or what the GPU filter is. But I don't need to necessarily have all that information in my head anymore. I can just kind of have it, and Kira will translate that question. So if you were a FinOps practitioner out there and you think of yourself as a non-technical person, I would still get it. I know this looks scary. I know the terminal seems scary. It's not that scary. You can also use the like Visual Studio, Kira, not Visual Studio, but that version of it, or get your devs to help you set this up, and then you can start asking these kind of questions and you'll be able to find out more information. That's where the hardest part of dealing with this kind of interface is making sure you're logged into the right account. And I'm not joking, it's just making sure you're in the right profile, and we should do a whole other episode on making sure that's right. Before we move on, 2 questions are in the chat, which is, would Kira have iterated automatically if there were multiple GPU instances? Liam?
Yeah, I mean, that's sort of up to the model's best judgment. And so what I would expect to happen is if I say, my engineer spun up 1 instance and it actually finds 2, that it would just, tell me, hey, I actually found 2. Do you want me to check both? Or maybe it would go and, get the cost and utilization data for both. But yeah, I would expect that it, would tell me that information and ask kind of what I want to do with it.
Yeah, do some investigating. And then, are rates different per region? Yes. Always check the pricing information. Things vary. Sometimes they're not, but I would always recommend checking the pricing information. Right, we have just under 10 minutes before we sadly finish our first episode back of the year. So was there one more demo section you wanted to do, Liam?
Yeah, so the last thing that Adam touched on was sort of getting into Bedrock tokenomics. And so let's do a little bit of analysis of our token usage and the associated costs in Bedrock. So I'm going to say, let's pivot. I want to deep dive our Bedrock costs in October. And what I'm going to say here is, can you break down costs and number of input and output tokens by model? So this is information that, yeah, you can get it from Cost Explorer. It'd be a little bit cumbersome to sort of filter for the right usage types and get the usage quantity graph to show up. But here I'm just going to type out my question. Again, it's going to run a Cost Explorer query. It is breaking down the data by usage type, filtering for Bedrock, and pulling both cost and usage quantity metrics. It's one thing I didn't emphasize earlier. It's really good to just also be able to audit, what is the specific query that the agent is making. You don't necessarily have to know how to write this yourself, but you can use this to just spot any issues or anything where it's misinterpreting what you meant. But what we can see here is in this account, we spent a grand total of $1.64 on Bedrock. Yep. So we're really going to have to optimize that heavily. And we can get the breakdown by input and output tokens for each of the models here. So that's exactly what I was looking for. Oh, and then I forgot to ask it something else. What is the cost per million input output tokens for each model?
And just before, so someone, I won't bring this up, but someone was asking where to get the GPU utilization metrics. There's a link in the YouTube to get that data.
Okay, so I can see the cost per input and output token for each of these models, which is great. And then the last thing that I want to look at here is looking at not cost per token, but cost per invocation. So how much does it cost every time I actually invoke one of these models or use one of these models, considering how many input tokens are used and how many output tokens are used. So let's say, can you calculate cost per invocation for each model?
That's an important question that Liam is asking, because sometimes when you just look at tokens and you can see like 1 million output tokens, it's important to know, like, okay, well, was that one person's question, one invocation that resulted in 1 million output tokens? Or has that been thousands of invocations? So then you get a little bit of like an idea of how your Bedrock or your AI is being used and how it's being spread across requests. Because think of invocations as just like requests.
Yeah. And someone asked in the chat, are we using Q? No, this is Kira. I can tell by the purple in it that this is Kira.
Yep. And the Q CLI actually was sort of reborn as the Kira CLI.
Yeah.
So that's the sort of latest and greatest. So let me catch up on what the agent is doing here. So I asked for cost per invocation. The first thing that it did was try to get invocation counts from the Cost Explorer data, but that's not actually available there because the Bedrock isn't charged per invocation, it's charged per input token and per output token. And so it tells me, okay, we would need to look at CloudWatch logs or metrics or check CloudTrail for invoke model API calls. All of those I think are valid potential paths. I said check the CloudWatch logs, and then it started to do that, and then I was like, wait, I actually meant the CloudWatch metrics. And so it's going to list the metrics in the Bedrock namespace. Okay, found the invocation metrics. Now it's going ahead and gathering the metrics for each model.
And even though this seems like complex, because Liam's truly given you like the details of what this thing is doing, as Steph kind of pointed out earlier, though, like you don't have to need to know how to go to CloudWatch, how to surface any of this data from CloudWatch. Just knowing that it's out there and telling this thing, hey, just go get it from CloudWatch for me. I just want to know the output, and it's doing it for us is, again, really powerful, especially for us FinOps folks that don't even normally think about or deal with CloudWatch. We usually live in the Cost Explorer kind of curve world. This opens up a whole new element of ways that we can understand the stuff that's going on in our environments. And I think it's going to be an evolution of how we do FinOps to be able to be more aligned to the business and understand how resources are being used.
Yeah, definitely.
All right, and it looks like we got our answer here. So we got the number of invocations for each model, total cost per invocation, and then average number of input and output tokens. So that's great. It did, it tried a few different things for how to get the data from CloudWatch, but like I said, it was able to kind of course correct and figure out the right approach, and ultimately get the data here. So just to wrap up what we looked at here. Adam walked us through 3 different ways to optimize costs for AI workloads, and then we showed how we can do them using the MCP server. So we looked at on-demand pricing versus capacity blocks for ML. We looked at Bedrock tokenomics, and we looked at GPU utilization metrics, and I didn't have to click through a bunch of different consoles and consult documents and write a bunch of API calls to be able to do this.
Yeah, the freedom of time, and also I just feel like the syntax is a big one where I remember writing CLI commands and like trying them out, and it just takes so long sometimes, and it even showed like it makes mistakes and it resolves it quicker than you would trying to go and Google and find these things out. Recommend trying it. Everyone here, go and download Kira CLI and have a go. Someone just asked as well, does it save your context? So with the CLI, it doesn't save your context if you leave it, but what you can do is the save and load command in Kira CLI, so that you can kind of save your past conversation and then bring it back in. There was a blog which just got
The other
released.
thing, if I can just add on to that, because I've been doing this a lot lately, just for my own personal productivity, is you can have Kira or any other sort of CLI tool, for example. You can just give it any number of like markdown files, for example, to give it context. And so recently, what I do is I feed it documents. I also, this is a little bit advanced, but I gave it a skill so it can like convert, Word documents or PDFs into Markdown files. And so I'm just like, hey, read this document, make sure you understand it. I gave it some instructions for like processing that context. And I've done this for a couple of weeks now. And now I load up Kira CLI with my special agent configuration, and I can just be like, hey, what are my priorities for today? Or like, I need to work on this problem, and it immediately knows like who I am, what projects I'm working on. So you can create something really powerful, basically just by using Markdown files.
Yeah. Brilliant.
If you're on Windows, one thing, Steph, you won't be able to install Kira CLI. You'll want to use the Kira IDE. So the CLI works on Linux or Mac. If you're on Windows, you'll want to grab the IDE. And the IDE does keep your history, your chat history. So it'll be right in there.
Is that using tokens to feed that into context? No. Am I right? Context doesn't use tokens, does it?
It does.
It does.
So,
steering.
So we're getting a little bit off topic here, but I could talk about this all day. The way that I set this up is when I feed it a document, I gave it instructions to write a short summary for itself, and that gets fed into its context, and then put the whole document in another folder that it can access when it needs to. And so it gets a short summary of the document. And then if it needs the whole document, it can use my file system and actually find it and read the whole thing.
I feel like we need to get Liam on to walk us through his background of what you set up. I'm aware that we have 1 minute left, so I might want to ask Adam, what were you going to say?
I was going to say the context does matter on the input side as well, because over time, even though the output was 4 times more expensive than input tokens, with enough context and all that prior chat history, that all gets jammed into your input side. So it can get can become very relevant there as well to do things like Liam did, where he's summarizing stuff.
Yeah. Brilliant. So a couple of things before we leave. Follow the Customer Acceleration LinkedIn group to find all the cool things that our department does and other episodes and whatnot. Also, my other show, How to Build Like AWS, is coming back soon in February. I think February 22nd. So follow me on Builders Center to be able to see what episodes are coming up, which will be on this live stream on Mondays. With that, I saw some comments that didn't get answered today, some questions. Thank you so much, everyone asked questions. Well, amazing audience today. Thank you so much, folks. Where you're watching this on YouTube, when we go off live stream, you can then comment under the YouTube channel. Please comment your questions there, and I will take care of them. So just wait a beat until we finish this and just refresh your page. And the very last thing is our secret Richard summary. So I have not seen this, so it's going to be a fun little summary for me to summarize the show. So number 1, check out the short-term commitments for capacity blocks. Yes, monitor those GPU utilization, oh my goodness, monitor GPU utilization for low. Usage. Oh my goodness, my brain. Use system prompts to reduce response tokens, and AI for FinOps tools quickly execute low-level tasks so you can focus on the higher decisions. And with that, folks, that is it. We will see you all next week where we continue on of our 6-week set of reInvent deep dives. So we'll see you all next week. Thanks, folks. Bye.
Thanks, everyone.